Okay, so we are on to the unit number 3, that is knowledge, representation, and reasoning. So we have seen what is knowledge, what is representation, and then what is reasoning. So all these three are very much important and as a part of the entire process happening in artificial intelligence. And these three are very much important and required in order to make AI system as an AI. So we have seen a lot of things regarding the knowledge, representation, and reasoning. Individually, we have seen what are they, and together how they play an important role. Like what is knowledge, we have seen. What is representation, we have seen, like symbolic structure representation. Then see, we have seen reasoning. Beyond that, we have also seen that knowledge representation, that is called as KR, and then ultimately KRR, that is called as the knowledge representation and reasoning. So all these things we have seen. And the most important point of the last lecture was the requirement of a knowledge representation system. So we will start from there and we'll move to the next points. So what is the requirement of a knowledge representation system? The first is, we have seen that it is an expressiveness. So that means it should be expressive enough to work effectively. Second, we have seen is a representational accuracy, that is capable of representing all the required knowledge. They should be capable. Then inferential adequacy, that is the knowledge-based system must be able to manipulate the representational structure to produce new knowledge with the existing structures. This is how it goes. The inferential efficiency is nothing but should direct the inferential mechanism into the most productive direction by sorting out the appropriate guides. Then acquisitional efficiency is the ability to acquire new knowledge using automatic methods. Semantic clarity, it should have clear and well-defined semantics. So we have seen what is semantics. Meta reasoning, the system should be capable of introspecting on its own knowledge. So meta reasoning is quite an hot topic, I could say, as far as AI is concerned, because it deals with the introspection of its own knowledge, whatever it has achieved, whatever it has learned from. And because of introspection, we find this system, AI systems, to be a very foolproof and keep on improving. Then the next point, we will start with the new point, that is representing and reasoning. So now representation and reasoning will be a very important point further in order to take out these points. That is about objects, about relations, about events, about actions, about time, and about space. So we are going to see this representation and reasoning of all these things amongst this. So we are going to find out the representation of reasoning related with the objects, then the relation between these objects, events happening between these objects, actions that is been taken, and the time and the space. All these parameters will be coming together in order to represent and reasoning concept. So we are going to see one by one how these things are correlated with each other. So let us start with the one concept called as an reasoning, and that is ontological reasoning. This ontological reasoning need to be understood first. It is related with the reasonings that are related with the actions, times, objects, and beliefs. So whatever the actions you take, at what time it is taken, what are the physical objects on which the reasoning can be done, and the beliefs that are been strongly behind it. So the ontological reasoning is nothing but, actually it is nothing but representing the abstract concept, or I could say that the reasoning between action, time, physical objects, and beliefs. Now, next one, when we understand this ontological reasoning, there are some categories that are been important as far as the aspects of general knowledge and reasoning is concerned. So mostly there are two types of categories as far as the first order logic is concerned. Now, in order to understand this first order logic, we are going to see in the next coming points where we are going to see this first order logic. But let us first of all see how these two choices goes into the categories. So let us understand first the categories. And when it comes to the FOL, which is also called as first order logic, we will see in the coming lectures. Then we'll go in little bit detail and you understand better this also. So there are two representing categories which comes into the picture. One is a predicates and the other one is an objects. So the first one is the predicate. That is example, if you take basketball X, that is called as the predicates. And if you want to say the objects, that means the category as an object. Basketball is nothing but the category of an object, which allows us to say member X, comma basketballs. So we can say that X is a member of a category basketball. So we could say that there is a category of a basketball. So X is a basketball, whereas the basketball is the category. So this is nothing but the objects. So there are two things: is basketball, which is X, and the object is nothing but which is said to be as X, which is a member of the category called as basketball. So this X is a member of a category called as a basketball, right? So henceforth, this category representation is very much important. Categories can be also belong to these subcategories. So again, when we see it as two categories, then it is again divided into the subcategories. So what are the subcategories? The first one is taxonomy or taxonomic hierarchy. Second one is inheritance. Third one is a disjoint. Fourth one is a partition. Actually, disjoint is having exhaustive decomposition and partition, and taxonomy hierarchy is having this inheritance. So all these things are related with each other. You need to understand about the categories, because once you understand the categories, then you can understand better way that how the reasoning can be done. So we have seen there are two types of categories. First one is a predicate, that is a basketball X. The second one is an object. So X is the member of the category of a basketball. Sorry. Now these categories can be divided into the subcategories. The first one is a taxonomy hierarchy, organization of category and its subclasses. So it is nothing but the categories and its subclasses, right? So like if I'm going to say, the better way to understand is having a hierarchy of like organization of categories. If there is a category of a basketball, then it comes under the subclass of an ball. So there are categories which have to be understood. The inheritance and object or subcategory inherits the properties of the upper category. So if you consider the taxonomy or the taxonomic hierarchy, then it is clear to understood that there is an organization of the categories and its subclasses, right? Inheritance is nothing but the object or a subcategory which inherited the property of the upper category. So this inheritance is nothing but which is a subcategory, or it is an object which has the inheritance of the properties of the upper category, which is nothing but the taxonomy and hierarchy. The second one is the disjoint. Two or more categories are disjoint if they have no members in common. So if they don't have a common things, then we can say that they are disjoint. That means they are not connected. Exhaustive decomposition, for example, if an animal is not male, then it must be female. That is called the exhaustive decomposition. And then the partition, a disjoint exhaustive decomposition is called as an partition. So all these things will comes under the subcategories. We have seen two categories, predicates and objects. And then we have seen the subcategories. The first one is a taxonomy hierarchy. The second one is a disjoint. As far as taxonomy is concerned, it is the organization of the categories and its subclasses. How you organize these categories and its subclasses is called as the taxonomy. So when this subcategory inherits the property of the upper category, it is called as the inheritance. And disjoint is nothing but two or more categories which are disjoint if they have no members in common. If they have members in common, then we can say it as a joint category. But as far as two or more categories are disjoint if they have no members in common. And if the animal is not male, definitely it is a female. This concept is an exhaustive decomposition. And when a disjoint exhaustive decompositions comes together, it is called as the partition. See, these are the concepts that comes under representation and reasoning about objects, relations, events, actions, times, and space. So all these things are related with each other. One by one, we'll be seeing about these events, objects, and the relationships between them. Then comes physical decomposition, the idea that one object can be part of the another. This is called as the physical decomposition. So the idea that one object could be the part of another object means there are two objects. If two objects are separate, then we can say that they are two objects. But sometimes there may be category where one object could be a part of the another one. So that is called as the physical composition. The second one is composite objects characterized by structural relationship amongst the part. So composite object is nothing but it's like a it's a part and where the structural relationships between the parts are done. And the characteristics of that thing is nothing but the composite objects. Then comes the measurements. Objects have weight, height, mass, cost, and so on. The values that we assign for these properties are called as measures. So actually these are the objects which will be having some height, mass, cost. And when we assign value to them or to these properties, then we say that it is called as the measure. Understanding this is very important. The values that are been assigned, the values that are assigned to these objects are nothing but the measures. Then comes individualization. It is nothing but division into distinct objects. So there are some objects, and when we divide these objects into distinct objects, then we say that it is an individualization because it becomes an individual object. Now it is not part of that object because we have divided into distinct objects. We can take also an example. Suppose I have some butter and an advak. I can say that I have one advak, but there is no obvious number of butter, right? Na? We can say that there is advak, but we cannot say butter is not having the value. So any part of the butter object is also a butter object. However, if I cut an advak in half, we don't give two advak, unfortunately. So even if it is converted, we cannot say it as an half. And butter does not have an numbers to say that this much of butter. So obviously this is nothing but the individualization. Then comes the intrinsic properties. The properties that belong to every substance of an object rather than the object as a whole. एक पूरा क्या बोलते पूरा ऑब्जेक्ट को अगर मैं बोलूं तो उसको नहीं कंसिडर करना है, बोल कि every substance of that object is nothing but that property is called as the intrinsic property. So you might have seen also the intrinsic and extrinsic properties, like I could say that the most important part, like example, we can say that intrinsic and extrinsic type of semiconductor you might have seen. So what was that intrinsic and extrinsic semiconductors, what we have seen of the properties? Like intrinsic is a pure one, and when something is added into it, it is called as an extrinsic. Some thing is added to that, then it becomes an extrinsic, that is called as the impure. Similarly, this intrinsic object is nothing but it belongs to each and every substance of the object rather than belonging to the object as a whole. So example, you can say that density, density of that object, boiling point of that object, flavor of that object, color of that object, ownership of that object. So these all things are nothing but the intrinsic properties. Next will be the extrinsic properties. So I said that something is added to make it impure is an extrinsic. So properties that are not retained under subdivision. So जो ऊपर वाले में जो subdivide नहीं कर सकते, तो बचे हुए जो प्रॉपर्टीज है वो एक्सट्रिंसिक में आ जाएंगे. ऊपर जो होते हैं वो इंट्रिंसिक, नीचे जो आते हैं वो एक्सट्रिंसिक. सो ऊपर में जो हम वैल्यूज जो ऐड कर रहे हैं, वेरी सब्सटेंस ऑफ एन ऑब्जेक्ट, राइट? So very substance of an object, that could be density, boiling, and all those things. So which we are not retaining in under subdivisions, that may be weight, that may be length, shape, functions, etc. All these things are nothing but about the extrinsic properties. So the properties that are not retained under subdivisions are called as extrinsic properties. Then the most important, time and event calculus. So all these things, see, this is a time. Here we are seeing the relationships, we are seeing the objects, we are also seeing the events happening. So all these parameters that are been coming under this is been helping you to give an idea about how to represent and reason, the given reasoning about the objects. Now, what is this time and event calculus? So obviously the time and event calculus is nothing but it is about the situation calculus. It works well on a single agent performing instantaneously, like discrete actions. However, when actions have durations and overlap with each other, event calculation should be used. So obviously, suppose there are two types of calculation that comes into the picture. One is your event calculus and the other one is a situation calculus. So situation calculus is like a discrete, it isn't discrete. एक एक इवेंट हो रहा है, उसका कैलकुलेशन हो रहा है, दूसरा इवेंट हो रहा है, उसका कैलकुलेशन हो रहा है. लेकिन when these events starts overlapping each other or when the actions having durations and overlaps with each other, then at that time we are going to use event calculus. Otherwise, in another situation we can use the situation calculus. So these are the two different things that has to be understood. Situation calculus we are going to go in deep again in the coming lectures, but first you understand this, that there is an event calculus and there is a situation calculus. So when a single agent is performing instantaneous discrete actions, it is called as the event calculus. And when these actions have a durations and overlap with each other, then we said to be as an event calculus. So this is most important to understand event calculus and situation calculus. Now we'll little bit go in depth about event calculus because we are having this point as event calculus and situation calculus because they are very important points and they are been like in individual important points. So let us little bit go with event calculus. So what I said about the event calculus was the actions have a durations and they overlap with each other. So एक एक्शन हो रहा है, दूसरा एक्शन हो रहा है, तीसरा एक्शन हो रहा है. ये एक्शंस का अगर ड्यूरेशंस ओवरलैप हो जाएगा उस वक्त हमको इवेंट कैलकुलस लेने पड़ेंगे. मगर डिस्क्रिट फॉर्म में अगर इवेंट कैलकुलस हो रहा है तो हम इस सिचुएशन कैलकुलस के लिए जाएंगे. हमने ये देखा. Now how this event calculation actually works out, we'll little bit see. So there are some of the parameters that comes under event calculus also. It is based on the points in time rather than situations. So obviously जो duration है, जो period है, वहां पर टाइम पिक्चर में आता है और वो जो ओवरलैप होता है उस वक्त हम इवेंट कैलकुलेशंस यूज करते हैं. तो इट इज बेस्ड ऑन द पॉइंट्स इन टाइम रादर देन द सिचुएशंस. सेकंड, in event calculus, fluents, that is functions or predicates that vary from one situation or time to the next, hold at a time in rather than at a situation. So in event calculus the fluents are there. So the fluents are nothing but the functions or predicates that may vary from one situation to the another situation. So these functions or predicates are nothing but fluents. So they hold at a point in a time rather than the situation. So पूरे situations को calculate करने के बजाय एक time में वो capture होता है, वो event calculus में हो सकता है. So it is related with the time. Are you understanding? See, in event calculus, there is a fluent. Fluent means the function or the predicates that vary from one situation to the another situation. When these fluents hold at points in time rather than in situations, then we say that it is about the event calculus. It is designed to reason over intervals of time. Obviously, there will be time and interval that will be coming into the picture as far as event calculus is concerned. Then in event calculus, axioms say that fluent is true at a point in a time if the fluent was initiated by event at some time in the past and was not terminated by an interviewing event. This is also very important property. अब an event calculus में axiom एक concept है event calculus में. अब वो axiom ये बोलता है कि fluent true होगा तभी जब ये fluent जब एक इवेंट शुरू हुआ चुका था पास्ट में और वो टर्मिनेट ही नहीं हुआ. सो जो इवेंट शुरू हो चुका था वो जो टर्मिनेट हुआ नहीं है, ऐसा अगर कोई फ्लुएंट होगा तो उसको हम एक्सियोम बोलते हैं. That is nothing but event calculus axiom. When event calculates the axiom which says that fluent is true if the fluent was initiated by the event which started sometimes before in the past and was not terminated, then we say that an event calculus axiom is calculated. Understanding somewhat difficult, but you have to manage because as these concepts are new concepts. The initiates and terminates relation play a similar role to the results relation in situation calculus. So as far as event calculus and situation calculus is concerned, there are 2 points which are important. One is initiate and the other one is a terminate. So their relationship plays the similar role as in situation calculus. So जैसे event calculus में होता है initiate और terminate के बारे में या उनके relationships के बारे में, similarly we will be seeing in a situation calculus. So अभी initiate और terminates है क्या, जो कि situation calculus में भी same है और event calculus में भी same है. So initiate मतलब E, F, T means the event E at time T causes fluent F to be true. So that is called as the initiate. It's like an initialization. Means एक event को initialize करना है at time T और जिसके वजह से fluent F होता है. So EFT एक event होता है at time T with F to be true. So उस वक्त F true होगा जब event at T शुरू होगा. So that is called as the initiates. And the second one is a terminates, which is nothing but WFT, which means that event W at time T causes fluent F to be false. So the first one is about the true and the second one is about the false. So this false means it terminates. This is true when it initiates. And the third concept that comes into the picture is happens. That is ENT, means E happens at time T. So E will happen at time T. That is nothing but the happens. So happens will be into the picture when you consider them as the event happening. So happen S, initiate and terminates. So EFT, so event E, time T causes fluent F to be true. Terminates, event W, time T causes fluent to be false. Happen S, E comma T means event E which is happening at time T. This is called as the happen S. And then comes the clipped, that is F comma T1 comma T2. So now here what does it mean? What does it mean? It means that fluent F is terminated. This fluent F is there, which is terminated at some time between T1 and T2. Understanding? So let us see once again what does it actually means. These are the most important concept that comes into the picture. See, event calculus is different from the situation calculus. Situation calculus is like a discrete, but in case of event calculus, there is an overlapping of the events happening during the period of time. It is the based on the points of time rather than the situation. Situation पर पूरी तरह डिपेंड रहने के बजाय ये टाइम पर डिपेंड करता है. और इवेंट कैलकुलस तब होता है जब फ्लुएंट होल्ड करता है टाइम रादर देन अ सिचुएशन. बराबर. सो सारा खेल टाइम का है, सिचुएशन का नहीं है. इट इज डिजाइन टू रीजन ओवर टाइम ऑफ इंटरवल. सो अगेन इंटरवल ऑफ टाइम पर डिपेंड करता है. सो अब इसमें दो चीजें हैं. एक चीज ये है कि इवेंट कैलकुलस एक्सियोम जो है वो फ्लुएंट को तभी ट्रू बोलेगा जब जो फ्लुएंट पास्ट में शुरू हुआ है और अभी तक टर्मिनेट हुआ नहीं है. ऐसे चीज को हम कैलकुलस एक्सियोम बोलते हैं. So this is happening in event calculus. The second most important is that initiates and terminates are those two things which are having some relationships and they are having similar roles as in case of situation calculus. So दोनों में भी तकरीबन सेम ही है. Now, what is this initiate? It is nothing but event E happening at time t, which causes the fluent F to be true. What is terminates? Event W, that is at time t, causes the fluent F to be false. What is happen S? E comma t means E is happening at time t. And then the clipped F t comma t1 comma t2 means fluent F1 is terminated at some times between t1 and t2. Now this gives us the functionality similar to situation calculus. It is very much similar to situation calculus, which we are going to see. बिकॉज दोनों में से कोई भी एक चीज भी लिया जाएगा तो आपको वही इशू होते थे, इसीलिए मैंने इसको पहले लिया, बाद में सिचुएशन कैलकुलस लेंगे हम. So this gives us the functionality similar to the situation calculus, but with the ability to talk about the time points, जो कि situation calculus में नहीं होता, and intervals. Examples happen as, that is turn off light switch 1 at 1 means light switch was turned off at 1. So how can you use this happens E comma T? That is nothing but this event E is nothing but the light switch. And what is this T? That is at time. So light switch will be turned off at 1. This is called as the happen S. This is all happening around artificial intelligence. This is all happening around the calculus. And we have been finding out the relationship between objects, relations, events, actions, and times. Next point, extensions of event calculus to address problem of indirect effects, event with duration, concurrent events, continuously changing events, non-deterministic effects, causal constraints, etc. So when we are doing all this calculus, event calculus, in order to address the problems, then we are going to consider different types of events. That may be events with duration, that may be the problems that is related with indirect effects, that may be problem related with the concurrent events, continuously changing events. यानी बहुत सारे अलग अलग तरीके की event calculus हम कर सकते हैं. It is not about a single type of event, but it is going to vary with, it is going to work out with different types of events, and that is what the event calculus can take place. Now, next important point is generalized events. So now we have seen situation about the situation calculus. We have seen about the event calculus. We have also seen the ontological events, different events. We have seen axioms. We have seen fluents. So all these things are very much related with each other. Now let us see some of the generalized events that will take place and how these are important as far as the events, action, times, and space is concerned. Now, generalized event is composed from the aspect of some space-time chunk. For example, World War II is an event that took place at various points in the space-time. It can be broken down into sub-events. That is a generalized event. So then event has occurred like World War II, and we can break it into sub-events. So what actually we are doing is that we are considering the space-time chunk. Actually, space-time chunk is nothing but you're breaking down the events into sub-events, and that is nothing but the generalized events. Now, in these generalized events, if you look at the sub-events that has been happening, then we can also find out the intervals. So intervals are nothing but the chunks of the space-time that include all the space between two time points. So there is a space-time chunk because we have broken into sub-events. So दो time points के बीच का जो interval है उसको intervals of the chunk of the space-time interval बोलते हैं. क्योंकि break किया, there is a World War II. So this is an event. We have broken the World War II into different sub-events. In these sub-events, there is a space-time, there is a time, and the space between two time points is called as the interval. Next, period. It denotes the smallest interval enclosing event E. So, दो तीन events के बीच में जो smallest interval आप calculate कर सकते हैं, उसको पीरियड बोलते हैं. Understand? This is the smallest interval enclosing the event E, and duration I, the length of the time occupied by that interval, उसकी length. So दो इवेंट के बीच का जो टाइम इंटरवल है, स्मॉलेस्ट टाइम इंटरवल, उसको हम पीरियड बोलेंगे. और जो द लेंथ ऑफ द टाइम जो कैलकुलेट करेंगे ऑक्यूपाइड बाय दैट इंटरवल, इट इज कॉल्ड एज ड्यूरेशन. So we are into the generalized events only, but we are seeing the sub points of it. We can take an example like any other sort of objects. Generalized events can be grouped into categories. Like World War II belongs to the categories of war. Obviously, if we categorize it into like basketball, so it was having a category of a basketball. So X is a category of a basketball. So similarly, World War II belongs to the category of wars. Basketball belongs to the category of ball. So World War II belongs to the categories of wars. So in this war, you can calculate generalized events, that is breaking down into sub-events. You can calculate the intervals between these wars. You can calculate the period E, you can calculate the duration I. Everything you can calculate. Like any other sort of object, generalized event can also be grouped into different categories. Understanding? Then comes process. So generalized events हमने देखा, अभी process देखते हैं. So process में first आएगा discrete events, events that have a definite structure. So which events will be discrete events? Obviously discrete interval यानी कि definite structure है. Liquid events or the process categories, it is nothing but sub interval of a process, is also called as the member of the same process category. Temporal substances, that is liquid events. Spatial substances, things like butter. So these are the spatial substances जिनको हम categorize नहीं कर सकते, जिसको हम break नहीं कर सकते events में. Those substances are called as the spatial substances. Example is butter. Temporal substances like liquid events, and discrete events that may have a definite structure. So all these things are related with representing and reasoning about the objects. Next, we'll be going deeper and deeper into these parts. Next, we invent a time scale and associate points on that scale with moments given as an absolute times. So obviously the whole event is been calculated and associated points is on the scale of the moment with the help of time. The time scale is arbitrary. We measure it in seconds. Like in midnight on January 1, 1900 has time 0. The function begins and end pick of the earliest and latest moments in the interval. This is all about time interval. And the function time delivers the point at time scale for a moment. The function duration gives the difference between end time and start time. Just read it, you'll understand the things. To make these numbers easier to read, we can also introduce a function date, which takes 6 arguments like hours, minutes, seconds, days, month, and year. So these are 6 arguments that could be considered as far as date is concerned, and returns a time point, that is 2 interval meets if the end time of the first equals and the start time of the second equal. So again, that is nothing but the intervals. It is nothing but about the date having 6 arguments. This is all about the events, and that is related with the time. Then we have also seen fluents and objects, which we can also say with example, we can explain. The physical objects can be viewed as a generalized event. So we can say that the physical object can be looked at as a generalized event, that the physical object is a chunk of a space-time. So physical object can be also viewed as generalized events, means it could be also viewed as a chunk of space-time. Example you can take. Like example, USA can be thought of an event, right, which began in 1776. So USA का जन्म हुआ 1776 में, और as a union of 13 states, so 13 states मिलके एक USA बन गया, and it is still in progress today. So पास से शुरू हो चुका था, टर्मिनेट अभी हुआ नहीं, चल ही रहा है. अभी कितने states बन गए? 50 states. So to describe these changing properties of the US, we use fluent. Also example, you can say the population of US, which is always changing, which has not terminated. So all these things comes under fluents and objects. We can take an president of USA denotes a single object that consists of different people at different types. So even though US president of USA is a single object, but it is going to vary at different types. So all these things are about the fluents and objects. So this was about the event calculus. This was about the categories, then into subcategories. This was about the intrinsic and extrinsic categories, properties. Then about the physical composition, the composite objects, measurements and individualization. Then we have seen time and event calculus. So we have seen in detail about the event calculus. We have seen about the generalized events. We have seen about the processes. We have seen about the fluents and objects. Now we'll move towards the situation calculus. So event calculus के बाद एक सबसे important जो कोई concept है तो वो situation calculus है. So as we have seen already that what is event calculus and what is situation calculus. Situation calculus is not related with the time, it is related with the situation. It is having, even if you want to define it in time, you'll go with the discrete time. And whereas the event calculus is concerned, it is nothing but the overlapping of the situation, overlapping of the time duration of the event or of the situation. So now we are going to go a little bit in detail about the situation calculus after event calculus. So situation calculus is a logic formalism that was designed for the purpose of representing and reasoning about dynamic domain. So you know static and dynamic. So this was specially been designed for the dynamical domains. So the domains where you have the dynamic behavior, not for the static behavior. It was first introduced in the year 1963 by a computer scientist and a cognitive scientist called John McCarthy. So in artificial intelligence, you will be hearing this name very commonly. And it's a very renowned name who has been worked for the artificial intelligence, who has been a father of AI, is John McCarthy. The main idea behind it is that reachable states, whichever we refer to as a situation, can be defined in terms of actions that are required to be done in order to reach those states. So situation calculus is nothing but it is about the reachable states. It could be defined in terms of actions that are required to be done in order to reach those states. So events that are been happening and that you can reach to the states of those events. In order to reach those states where you can take the terms of actions is nothing but the situation calculus. What holds true in situation can be defined in terms of relations using the situation as an argument. So this is the most important line which we can say, that what is this situation calculus? So if you could say that the situation can be defined in terms of relationships. So obviously एक दूसरे से relate होने वाली जो चीज है वो situation में रहती है. So situation is nothing but it defined in terms of relationships, and in that situation is used as an argument. So this is hold true in this situation. What is true in this situation is that we are going to define the situation in terms of relationship where the situation is an argument. If this thing happens, then we say that it is a true to situation, true, which holds true in the situation. Essentially, you can pretty much be consider situation calculus to be feature-based representation of an action. So it is nothing but about the actions. So it is nothing but about the feature-based representation of actions. Only single agents, a fully observable environment, and deterministic actions are considered here. So for the situation calculus, only single agents, full observable events. So एक ही agent काम करेगा, fully observable environment काम करेगा, और deterministic actions consider किए जाएंगे. अगर ऐसा होगा तो उस calculus को हम situation calculus बोलते हैं. Now we can consider an example in order to understand all these things together. Like a situation is either init, this is an initial situation. So I write this command as init, which is nothing but the initial situation. Or I could say do a comma s. Now this is the situation that arises because of performing action A in situation C. If it is possible to do action A in situation S. So दो चीजें हैं, दो टाइप के सिचुएशन है. एक बिल्कुल कुछ हुआ ही नहीं उस सिचुएशन में, जिसको हम बोलते हैं इनिशियल सिचुएशन, या फिर सेकंड में सिचुएशन हुआ है. सो उसलिए डू ए कॉमा एस. सो नथिंग बट द सिचुएशन दैट अराइजेस because of performing action A in situation S. So if it is possible to do action A in situation S, then we can say that there is a do. So we are into the situation calculus, and we have been seeing how this situation calculus can be explained. So one is an initial situation. As situation calculus is nothing but your calculation of the situation or the events that has been happening. How you calculate, how you do the calculus of the situation. So initial situations is nothing but called as an IN, which is represented by INIT, that is called as the initial situation. Or if there is an action happening, so we can say that do, that is the action A is performing in situation S, is called as do A comma S. There are some do A comma S terms that do not correspond to any state, but in some cases an agent will need to reason about such potential situation without possessing any knowledge about whether A is possible in state S or is S is possible at all. Obviously, when I say that there is some action that has been happening, that is the action A in situation S. In every situation this will happen, it is not true. In some of the situation it may happen like an agent will need to give the reason whether A is possible in state S or if S is possible at all. Because हर situation में नहीं, मगर बहुत से situations में वहां जहां जरूरत पड़ेगी, जहां agent will need to give the reason that if A is possible in state S, whether A is possible in that situation S, or if S is possible at all or not. So ऐसा भी हो सकता है. सिर्फ एक्शन लेना इस पर्टिकुलर सिचुएशन में ये काफी नहीं है. कई बार ऐसा भी हो सकता है कि आपको उसका रीजन देना पड़ेगा कि भाई ए पॉसिबल है कि नहीं उस सिचुएशन में, या फिर एस पॉसिबल है ही कि नहीं इन ऑल पॉसिबल वेज. दैट इज हाउ इट इज गोइंग टू डील विद. The ontology of the situation calculus is made up of situations, actions, and fluents. So again, what is made up of situation calculus? Obviously the situation that is going to occur, obviously the action A is going to occur, and with this the fluents F. So three things will be there which will be into the ontology of this situation calculus, that is S, A, and F. The situation can essentially be considered to be instantaneous snapshot of the world. Obviously जब कोई situation होती है तो वो उस instantaneous टाइम का एक स्नैपशॉट ही होता है. सिचुएशन आकर हो गई मतलब आप इमेजिन करके चलो कि वो उस पॉइंट का, उस इंस्टेंट का वो हुआ हुआ कंडीशन, हुआ हुआ सिचुएशन रहता है. सो इट्स लाइक एन इंस्टेंटेनियस स्नैपशॉट ऑफ द सिचुएशन. इट्स लाइक एन सिचुएशन. These are logical terms that are made up of initial situations and all the situation that arises because of the application of actions to the situation. कुछ ना कुछ एक्शन होता है सिचुएशन में, इसीलिए ये सिचुएशन अराइज होती है. हर सिचुएशन इनिशियल सिचुएशन के साथ होती है और वो डू की तरफ जाती है. कोई ना कोई एक्शन होता है, उस सिचुएशन एस में होता है because of the application of the action in a particular situation, and henceforth वो इनिशियल सिचुएशन से डू सिचुएशन में चला जाता है. A fluent could be anything whose value can be changed. So we have already seen what is fluent, जिसकी वैल्यू बदलती है. एग्जाम्पल हमने देखा यूएस का. यूएस 1770 में कुछ बना और उसके बाद वो अब तक बनता ही आ रहा है. तो it is an fluent represented by fluent. These are the essentially functions and predicates that array from one situation to another situation. Yes, obviously. A fluent has a value true if it holds in a situation. So obviously when I say a fluent is to be true, or when I say a fluent is a false, we have also seen that when it is said to be true and when it is said to be false. So fluent has the value true if it holds in a situation, and if its value is false if it does not hold in the situation. So fluent का जब अगर वो situation में नहीं hold कर पाता है तो it is true, hold कर पाता है तो true, if it is doesn't hold then it is called as the false. Okay, so we will see in the next lecture. We'll stop here because the power is gone. I don't know, at any time the lecture might be you might leave, so let us